All right. Two special patterns. These are what I call shortcuts. And everybody says, yeah, but I finally understand factoring. Do I have to learn the shortcut? And my answer to that is no, but when we get to the end of this unit, you won't have a choice but to know one of these. So it'll save you a lot of time if you go ahead and learn them. What do you mean we don't have? Like, we're going to do something at the end of this unit that uses one of these special patterns that I'm fixing to show you, so you'll have to be able to recognize it. So, Max, what are you supposed to do with your homework when you finish it? Not last night, Max. Okay. All right. I think I'll start with difference of squares. Is that easier or hard? This one's easy, but I think oh, let me exit out of this because it bogs my computer down. Now, do you have to know the names of them? No, you don't have to know the names of them. You just have to be able to recognize them. So tell me, what does difference mean? Subtraction, right? Subtraction, not different, but difference, right? So difference is subtraction. So this clues me in that I am subtracting. What is a square and not the geometrical kind? Geometric. Something times itself, right? So give me some examples of perfect squares. What? 9. 25. What else? 36. What else? 81. Give it to me. Give me a perfect square with a variable. 9x squared. What else is a perfect square? 49x squared. What if I said y to the 4th? Is that a perfect square?
Yes.
Why?
Because y2 can go in it.
Because y squared times y squared is y to the 4th, and that's the definition of perfect square. Yes? Can we all recognize perfect squares? Okay. Yesterday you had one of these, and you didn't realize it. Let me try to figure out where was it? It was the one, maybe it was on the back of the notes from yesterday. I think it was on the back of the notes. Do you see it? Look at that notes page I gave you yesterday. Yeah. That one. They're both perfect squares. Now, we took a GCF. This was number 3 on the back of your notes yesterday. We took a GCF out first, and what was the GCF? 4. And what did it leave me? Now, we went through and factored this one yesterday, right? When we factored it, because remember, it had to add to negative 9x squared, but it had to multiply to negative 9x squared, but it had to add to what? 0. What did we get when we factored it? We got 3 and negative 3. We got x minus 3, x plus 3. Remember? What do you notice about this relationship?
The opposite relationship.
Okay, well, it's the square root of each one with opposite signs in the middle. I think that's what you were trying to say. With opposite signs. That is the pattern. That is always going to hold true. If you have 2 different things that are both perfect squares, and there's a minus sign in the middle, that's very important. This does not work if it's a plus sign in the middle. Only when it's a minus, because it's a difference of 2 squares, not a sum of 2 squares. minus in the middle, two perfect squares, it will always, always, always factor to a minus b, a plus b. Always. If there's a minus in the middle, then it can't be factored. No, not two squares added together aren't going to be factorable for you.
Oh, yeah.
Not if it's a square, an x square.
It has to be minus.
It doesn't matter. Order doesn't matter because I can multiply in any order. Same thing as this. Easy enough? Okay. Okay. Give me a perfect square. Any perfect square in the whole world with a variable. Okay. Minus. Lillian, give me a perfect square. Any perfect square in the whole wide world. 9. Give me a different one. 25. All right. Both perfect squares, yes? Yes. Minus sign in the middle? Yes. So it's a difference of two squares. So if I were to factor this, if I'm doing this by hand, right? I'm multiplying 81 times negative 25, and I'm trying to find what multiplies to that but adds to 0. And holy potatoes, that's a big number, right? But if I recognize it being two squares with a minus, if I recognize it being a difference of two squares, I can shortcut it, and it's easy peasy. Because Max, what is the square root, or what times itself twice gives me 81x squared? 9 what? 9x. What times itself gives me 25? What is 5? 5. I do 1 minus and 1 plus, and it is factored. I didn't have to multiply the ends together. I didn't have to find those puzzle pieces. It's just done. It makes it easy, right?
Yeah. So we have to have time. That's only on that.
Only on that one. You have to recognize the pattern.
Why on the other one
So we took a 4 out first, and then x squared minus 9. Now, I could have gone here and said 2x minus 6, 2x plus 6, and then I have a GCF that I could take out. I could take a 2 out of this one and a 2 out of that one, and that's where the 4 comes in. So always take that GCF out first, if you can. All right, there's a difference of two squares, yay or nay? Huh? Yeah, because it had GCF, and I was trying to.
What if we have a B?
Then it's not a difference of two squares. Difference of two squares is only two pieces with a minus in the middle every time. Every time. Ready for the next one?
Yeah. No. I don't like that thing.
This is the one you'll have to use. Because it's harder. I will probably refer to this one as a PST. If you hear me say that, that is a perfect square trinomial. This one is harder to recognize, but easier to factor. So y'all stay with me, okay? Trinomial, what do you think that means? Three something, right? Three type of nomial. What's a nomial? I don't know. What's a nomial? 3 what? What'd you say? 3 terms. 3 terms. That's exactly right. All right. So I've got 3 terms here. Okay. Now, perfect squares refer to the ends of it. So that's requirement number 1. I guess requirement number 1 is that it's a trinomial, but requirement number 2 is that these ends are perfect squares. So I'm going to just put PS. Okay. That has to hold true. Next thing that has to happen is the last sign has to be a plus. The first sign doesn't matter. It can be anything. This has to be a plus. Okay? Perfect square plus. Now comes the hard part. it has to square it. I say square dance because it helps me remember. Okay. What do I mean by that? If you take the square root of this perfect square and the square root of this perfect square, have y'all ever heard of square dancing where they're like, do-si-do, take your partner? Okay. I'll make up a dance to it one year. What? Yeah, it could be either one. It could be either one. You take the square roots of the ends, square root, multiply and double. Okay. Square root, multiply and double. Okay. Ready? Do it with me. Square root, multiply and double. Now, why am I doing this? Why am I doing this and this? Because this middle piece has to take these two, multiply together, and double to give you what's in the middle. Okay? So let's say that this was a squared and this was b squared. Yes, because the numbers get so big. And I'll show you when I come up. All right, let me show you. Let me show you how it factors, and then I'm gonna give you some, and you're gonna tell me if it's a perfect square trinomial or not and what it looks like. This factors. Remember, this is all I'm doing is having you look at it and say, is it a perfect square trinomial? I haven't done anything with it yet. I'm still confused. Recognizing it's the hardest part. Take the ends and take the square root of both ends. That's right. If y'all ask me a question during the test, I'm going to go. Yeah. And you're just going to multiply and double. Yes.
So it'd be the square root of 8 and the square root of 5
and double. All right. Let me show you. Let me show you with a number. Yes, but it'll be a perfect square, so you won't have a square root anymore. All right, I just want to show you the end result here. If that all holds true, then this is how it factors. And this plus or minus is whatever you started with. Okay. So this is a squared. So whatever the square root of that is, this is b squared. So whatever the square root of that is. Okay, let me give you some numbers. All right.
Did we have one of these yesterday?
No. Yeah, you did. Which one was it that ended in a squared? Something squared. Number 7. Number 9. It was number 9. All right. The first thing I want to know is it a perfect square trinomial? No. I hear yes and no. I've got 3 things I need to check. No. Are the ends perfect squares?
Yeah.
Yes. Is the second sign a plus?
Yes.
Does it square dance?
Yes. No.
Yes. Okay, so let's look at it. Does it, all right, listen. What's the square root of the first one? 2x. What's the square root of the last one? If you multiply those together, what do you get? If you double that, what do you get? 12. Is this a perfect square trinomial? No, it's not. What needs to be in the middle to make it? This needs to be a 12, and now it is a perfect square trinomial. Do you see? Okay. Nope. If that happens, then it factors as 2x minus 3 squared. The hardest part is checking, is it a perfect square trinomial? I take it y'all have never done this before, though, because y'all are looking at me like this right now. Okay.
Can you not go to the answer yet and work through it? Wait, so 2x. It's just the square root of the 2 on the edge.
And the first sign. Double.
And then if it equals the middle, and then it equals 2x minus 3.
Why give what just?
I have a question.
I do.
I have a question. So, see how the first one is 4x.
No, I know. Why do you want to do
Square root of that was 2x.
What times itself twice gives you 4x squared?
So there's 9. Square root of
2x.
9. That's the answer, and that's squared.
Say it again.
4x or 2x.
How did the 3 become what? It takes on the first sign. Whatever the first sign is, it follows that.
Can you
Like not shortcut it?
so then see how they multiply?
How did I tell? Okay, what times itself twice gives you this, and what times itself twice gives you that? And this first sign goes in the middle. That's how it factors. If you slash that, you would get that twice.
Wait, how'd you get? Okay, I see. And it's plus 9.
Okay, some of y'all are freaking out on me for this. All right. Look at number 9 on your homework from last night. Well, or your homework from today, depending on when you did it. I'm just saying. 4b squared plus 12b plus 9. Whoop. Okay, don't do anything. I want you to check to see is this squared trinomial.
Yes.
Don't worry, Max. Three things you're looking for. Remember what 3 things you're looking for in second sign and square dancing.
You just bring down the
The first sign can be anything. It has to be.
But do you just bring down the plus?
You multiply the square roots of them. Yes.
And then it equals like the number.
Double it, and it has to equal the number.
It has to equal the number. So the first multiplied number doesn't have to equal the.
No, double. It's got to be doubled.
Did you bring down the first number?
Say that again.
Yeah, it's the same number.
Oh my gosh! Y'all! Okay. Stacy! Okay.
Can you shut up?
Okay, go. Yes or no? Hold up. All right. Shh. Yes or no? Yes or no? Don't blurt it out. Just look at it. Are the ends perfect squares? Is the second sign a plus, and does it square dance? Does it meet all 3 of those requirements? No, he cannot hear. No.
Can you do it?
All right, are the ends perfect squares? Yes. What times itself twice gives you 16? 4x. What times itself twice gives you 25? 5. Does it, oh, this is a plus. Does it square dance? Yes. Okay, how does it square dance? What's 4x times 5?
I was thinking they had to time into the number. Oh.
You see now?
So it is. I knew I was right.
Okay, so how does it factor now that you've recognized it? Any one of those things doesn't hold true, and it is not a perfect square anymore. Perfect square trinomial, okay? This is. All three. All three. All right. Now the good stuff. That's all the patterns I'm teaching you today until we get to polynomials, and then we'll learn some more patterns. So I'm going to teach you how to solve, and then you're going to practice with all the forms of solving. Okay? All right. What do I mean factor and solve? Now, all right, stay with me. Listen to me. Guys. All right. Now what happens? What if I had, let's say, this. And I said, what does x equal? What would your gut instinct be to do? Solve for x how? Minus 6. That's what everybody wants to do, right? Get x by itself, but there's two x's. If I move the 6, then I've got x squared plus 5x equals negative 6. But I couldn't take the square root of the, I don't think.
Divide all of them by x.
Well, but if I did that, then I'd have an x on both sides. Still don't have just one x. I'm setting you up, is what I'm doing, if y'all haven't figured it out.
Put them into two of them.
How did you know that?
Is it actually true?
Yes.
Factor it.
Okay. This only works when your equation is equal to 0. If it's not equal to 0, you're going to make it equal to 0. We can make that happen, right? We can make everybody go to the same side. We're going to make sure that holds true before we do any of this. Now, here's the premise of this whole topic here, or why we can do what we can do. If I've got it equaling to 0, and I can get it split up into something times something, and that equals 0. But it's the only way to get 0 when you multiply two things together.
0.
One or both of them has to be 0. Do you agree?
Yes.
That is what we call, so one or more must be 0. That's what we call the zero product property. When you multiply things together, at least one of those things must be 0 to get 0 when you multiply them. That just makes sense, right? It's the only way to get 0. So if I can get this factored, when I factor, aren't I just multiplying? Oh, am I? Yes. When you factor something, you're getting it into a multiplied form. So if I have x plus 1 times x minus 3, this is times right here. So if this equals 0, then to solve it, I would say, okay, well, x plus 1 equals 0, or x minus 3 equals 0. And then I solve each one individually. You remember it? Okay, so here are my steps. Here's what I'm going to do. I'm going to make sure my equation equals 0. Does it look weird? You're going to get 2 answers for most of these. Okay. You set each one equal to 0 because if they multiply together to give you 0, you do not have
X
to.
would be like -1. Well,
Right. 2 answers for these. Okay. Go down to this one. Step 1 is make your equation equal 0. That's your first step always and forever. Whether we're quadratics, polynomials, whatever we get to even further on down the line, that is your first step. If it wasn't equal, this is only when we're solving and it equals 0. But if this said like x squared plus 5x equals -6, I would need to move that 6 over here. Okay? Right. So I'm going to make a note here also to help you in your factoring. I'm going to put this as step 1. Make sure your leading coefficient, what is a leading coefficient? The one in the beginning in standard form, so the one that's hooked to what? X squared. So make sure your x squared term stays positive. So that's going to tell you which side to move everything to, okay? Most of yours you're going to start out today. Most of them will be equal to 0 when you start. You won't have to do this step, okay? But as we ease more into it, there'll be stuff on both sides. And you'll say, oh my gosh, I don't know. Should I move the right stuff to the left or the left stuff to the right? And you're going to look at that leading coefficient. And you're going to say, which do I move to keep him positive? Okay? Y'all tracking with me? Yes,
so you would always move it to a side with it.
for example. Right, if I had x squared plus 6x minus 5 equals 3x squared plus 15. Should I take the 3x squared and 15 and move it over? Or should I take everything else and move it to the right? Everything else is going to move to the right. Right. If I move this one, I'm going to end up with negative 2x squared. I don't want that, right? Instead, I'm going to move all of these guys over here. So now I've got 6x minus 5 equals, I'm going to move the 6x. And you can do this all in one step. I just want you to see exactly where everybody's coming from. Right. Even though that was more work to move everything to this side, that's what I needed to do in order to keep my leading coefficient positive. Does that make sense? Okay. Yeah, we're doing another one. All right. Yeah. I told you I'm a little squirrel. Okay. The original. The one we're running an example through. I was just showing you if it didn't equal 0 to start. That's right. That's right. Okay. Step 2. Factor. So mark, set, go. Factor that one. It's one extra step from what we've been doing.
It's pretty hard.
How many steps are going to be? How far do I need to go down?
One more after this. I think so too. Yeah. I can't imagine you factored without factoring and solving, because that's the whole point in factoring, is so that you can solve. I'm sure you did. All right. Get it factored? It's 2 times 3. Okay, go ahead. Keep going. It could be, yeah. Okay, where are we lost? Bless you. All right. Did everyone get it factored correctly at the very end?
I didn't do it right. I was like negative one.
The good thing about this lesson is it's so much repeat from yesterday that you practiced yesterday and learned yesterday. That's right. It doesn't matter. The order doesn't matter. All right, last step.
And then we go x plus 2 equals 0, x plus
Set each parenthesis equal to 0 and solve. Okay, so my parentheses here, x plus 2 and x plus 3. If I solve those, I get -2 and -3. That's it.
Me too.
That's it. That's it.
I remember doing this in this.
I think this was Lopez.